Welcome back. I guess we're ready for the example 2, but it's not going to be as hard as the very first one. The reason why I made the first one, well, it wasn't hard, but it was long, was to show you a few things all at once, which actually perhaps it wasn't the best and brightest idea in the world. So I'm just going to stick with something very simple here now. As my second example. Okay, so let's have a circuit in which we're gonna have our power supply and then a resistance, and then we're gonna have another resistance, and then we're gonna have like another power supply down here. Over here we're gonna have this. It's gonna make me flow the current in this direction. Okay, so basically I have E. It's gonna be my E1. It's gonna be my resistor 1. It's gonna be my point A. It's gonna be my point B. It's gonna be my resistance 2. This is gonna be my E2. So my second source of energy is gonna be J. And the problem is actually saying for the circuit below, in which E1 is equal to 2 volt, E2 is equal to 6 volts, R1 is equal to 10 ohm. Am I writing this okay? Yeah. And R2 is equal to 20 ohm. Find the value of J so that the current I is equal to 0. Okay, so it's really as simple as that. Okay, so basically I'm just gonna write what we have next to the letters. So E1 is actually 12 volts, E2 is 6 volts, R1 is 10 ohms, R2 is 20 ohms, and then we're gonna have to find the value of J. So if we set I, well, let me just say, okay, I'm gonna have this one is gonna be my I1. Okay, so the positive and negative, so the current is gonna flow this way, I1, and this one is gonna be my I. Okay. So if we set I1 equal to J and I equal to 0, then we're gonna have VAB equal to E2. And in this condition, I'm gonna apply the Kirchhoff voltage law to the left side. Okay, so to the left side, so to just to this side. So Kirchhoff voltage law, okay, to the left side. Okay, so those are my condition, and I'm going to apply the Kirchhoff voltage law on the left side. So here. Okay, so I can say that E1, remember what the Kirchhoff voltage law says? We have E1 minus J times R1 minus E2 is going to be equal to 0. Therefore, since we want to find J, J is actually going to be E1 minus E2, everything over R1. So J, if we substitute the value, is going to be E1, which is 12, minus E2, which we just said was 6 volts, so 6, over R1, which is just 10 ohms, so over 10. Therefore, all this, it's gonna be, well, it will be 6 over 10. Then we can just say, okay, just can divide those, and we can actually get J equal to, well, I'm just gonna write it as a fraction anyway, so 0.6 basically. It's just better to write it as a fraction actually. But I would use this notation instead. Because we are using circuits, so this one is fine anyway. J is just going to be 0.6 ampere. That's basically it. That's pretty much it. So let's go on and have another example.